Footprint Builder, an EDA Builder product from EMA Design Automation. On many of the component vendor websites, there exists model information, including the PDF datasheet, 2D models in DXF format, and step models. Footprint Builder can import 2D DXF models and overlay the model against the footprint generated by Footprint Builder. Footprint Builder has the industry's most complete set of header connector calculators, including circular, dB, dB micro, shrouded headers, and ZIF connectors. For this particular part, let's bring up the D micro right angle calculator. We will be modeling this part from the top view, the front view, and the side view, along with the table information contained in the table view. We will first start by bringing up the component tab and defining the number of pins and offsets. In this particular case, there's 4 rows with 9 pins in each row. And the offset starts at 0, a negative, a positive, and a negative. Executing the calculator automates the desired pin pattern for this particular device. We can leave pin 1 as a square or change it to a circular pin. Changing the pin pitch to 2.54 and 1.905 and recalculating. Using the associative editor, I will now click directly on the mounting hole to mounting hole spacing and changing the value to 37.6. I will perform the same function for the edge to edge spacing of 43.6. By clicking directly on the value on the screen, I will dynamically and automatically change the value in the corresponding form. Bringing up the side view, I will note that the edge to the center of the first row is 5.0. Bringing back up the side view, I will note that the total edge-to-edge spacing is 16.7. I will enter this edge-to-edge spacing in at 16.7. But going back to the side view of the data sheet, I will note that 16.7 included the 5.0 or the edge of the flange. Reducing the amount by 5.0, re-entering the value gives me the correct value of 11.7. Now let's change the length of the flange from 21.0 to the specification from the datasheet 33.39. I have now completed the modeling of the D micro part and I'm ready to import the mechanical data. Selecting the mechanical file browser, I will browse to the folder containing the DXF model. Selecting Open will import the model information directly into the browser. The first step will be to select a set of objects to crop. The second step will be to crop the selected objects. Once the specific objects are cropped, we can scale those if required on a scaled datasheet. The final step is to move the objects to the overlay scratch area of Footprint Builder. I will now mark an origin and drag the origin of the center point of the DXF model to the center point of the Footprint Builder model. You will now note that I have a corresponding match between the DXF file model imported from the DXF file and the generated model. I can also use other mechanical forms of data to verify the results. For example, opening up the step model will invoke the standard step browser associated with the file type on the user's machine. Although we do not currently support the importing of step models directly into Footprint Builder, there are several step browsers available for download by the mechanical software vendors. Now that I've completed the modeling, I will save the package and export the part directly to Allegro. We also support an export to PADS layout, which can be imported by a wide variety of tools in the PCB industry. Footprint Builder, an EDA Builder product available from EMA Design Automation.